Okay, those structures can seem difficult at first, but with practice they get a lot easier. So let's start out with a simple one and map out the steps that you need to do Lewis structures in general. So this question asks for draw the Lewis structure for HCN. Alright, so the first step that you want to do whenever you have to draw a Lewis structure is identify what is the central element. And usually the central element is the element that you have the least of, or that they've already gone to the trouble of putting in the center of the name, right? So in this case, C is in the center, indicating that C is the central atom here. So step 1, central atom, okay? And in that case, it's C. Step 2 is draw the skeleton. In this case, we have an H, we have a C, we have an N. We know the C is in the middle, therefore H and N have to be off to the sides. So H, N, right? And they have to be connected by at least one bond, so just go ahead and draw at least a single bond there, just a single bond. Alright, step 3, count electrons. Okay, so no matter what Lewis structure you're doing, that should be your next step, counting electrons. So carbon has 4 electrons, 4 valence electrons, right? So carbon is 4. Hydrogen has 1 valence electron, and nitrogen has 5. So the total number of valence electrons available here is 10. Alright, now the next step is very useful for relatively easy Lewis structures like this one. But as you get into more difficult Lewis structures, or as you get more familiar with Lewis structures, you might skip it. But we're going to do it for now. So the next step for now is shared equals need minus available. S equals need minus available. And this is going to tell us how many electrons are shared between the bonds, and therefore how many bonds we need to have. So shared, the S stands for shared, need, N stands for need, A stands for available. So each atom needs 8, with the exception of hydrogen and helium, right? And some other exceptions, but for now, hydrogen and helium. So carbon needs 8, nitrogen needs 8, and hydrogen needs 2. So when you add that up, 18. So need equals 18. I'm going to write need because we have a nitrogen there. That could be confusing. Available. We already did the math on that over here. So our available is 10. Therefore, our shared is 18 minus 10. Shared equals 8. So that tells us there's going to be 8 shared electrons in this problem. Each bond consists of 2 electrons. So 8 electrons divided by 2 electrons per bond gives us 4 bonds. So this Lewis structure, HCN, is going to have 4 bonds. In our skeleton, we already have 2 bonds drawn, right? One here, one there. 2 bonds. We're going to need to add another 2. Hydrogen can only have 1 bond, always, right? So that means that the carbon to the nitrogen is going to need to have 3 bonds. So let's go ahead and draw that. 1, 2, right? And now we have 1, 2, 3, 4 bonds. So this works. And then the last step is fill in lone pairs. So we've added all of our bonds. We just need to make sure that we've given all of our electrons a home. We had 10 valence electrons, and as counting here, we have 2, 4, 6, 8 drawn onto the structure. And on top of that, you can see that nitrogen does not yet have a full octet. Carbon has an octet because it has 4 bonds. Hydrogen has a duet because it has 2 bonds, but nitrogen is missing an octet, which is not good. So that last pair of electrons we're going to put on the nitrogen so that it has an octet. And now, when we count, you'll see that we've used up all of our electrons, 2, 4, 6, 8, 10, and everybody has an octet except for hydrogen, which has a duet. And also, something we'll talk about later is that the formal charge on these is all 0, which indicates a good Lewis structure.